Explore the mysterious and breathtaking world of Titan, one of the most enigmatic moons in our solar system, with never-before-seen final images captured by NASA's spacecraft. Witness the beauty of Titan's landscapes, from its methane lakes to towering mountains, and discover what these images reveal about the potential for extraterrestrial life. Don't miss out on this awe-inspiring journey into the unknown. What is Titan? Titan is the largest moon of Saturn and the second largest natural satellite in the solar system. It is the only moon known to have a dense atmosphere and is the only known object in space other than Earth on which clear evidence of stable bodies of surface liquid has been found. Titan is one of the 7 gravitationally rounded moons in orbit around Saturn and the second most distant from Saturn of those 7. Frequently described as a planet-like moon, Titan is 50% larger in diameter than Earth's moon and 80% more massive. It is the second largest moon in the solar system after Jupiter's moon Ganymede and is larger than the planet Mercury, but only 40% as massive. Mission on Titan. NASA's James Webb Space Telescope and the Keck Observatory in Hawaii have together captured Saturn's largest moon Titan in near-infrared. The new images reveal clouds in the northern hemisphere near Kraken-Mare, the largest known methane sea on the giant moon's surface. Titan is the only other body in the solar system that has rivers, lakes, and seas, though instead of water they flow with liquid methane and ethane. These hydrocarbons, as well as water and ammonia, also produce clouds and rain on the giant moon. Orbit and rotation. Titan takes 15 days and 22 hours to complete a full orbit of Saturn. Titan is also tidally locked in synchronous rotation with Saturn, meaning that, like Earth's moon, Titan always shows the same face to the planet as it orbits. Saturn takes about 29 Earth years to orbit the Sun, a Saturnian year, and Saturn's axis of rotation is tilted like Earth's, resulting in seasons. But Saturn's longer year produces seasons that each last more than 7 Earth years. Since Titan orbits roughly along Saturn's equatorial plane, and Titan's tilt relative to the Sun is about the same as Saturn's, Titan's seasons are on the same schedule as Saturn's, seasons that last more than 7 Earth years, and a year that lasts 29 Earth years. Structure. Titan's internal structure isn't entirely known, but one model based on data from the Cassini-Huygens mission suggests Titan has 5 primary layers. The innermost layer is a core of rock, specifically water-bearing silicate rock, about 2,500 miles, 4,000 kilometers, in diameter. Surrounding the core is a shell of water ice, a special type called ice VI that is only found at extremely high pressures. The high-pressure ice is surrounded by a layer of salty liquid water, on top of which sits an outer crust of water ice. This surface is coated with organic molecules that have rained or otherwise settled out of the atmosphere in the form of sand and liquids. The surface is hugged by a dense atmosphere. Formation. Scientists aren't certain about Titan's origin. However, its atmosphere provides a clue. Several instruments on the NASA and ESA Cassini-Huygens mission measured the isotopes nitrogen-14 and nitrogen-15 in Titan's atmosphere. The instruments found Titan's nitrogen isotope ratio most resembles that found in comets from the Oort cloud, a sphere of hundreds of billions of icy bodies thought to orbit the Sun at a distance between 5,000 and 100,000 astronomical units from the Sun. Earth is about 1 astronomical unit from the Sun, roughly 93 million miles or 150 million kilometers. Titan's atmospheric nitrogen ratio suggests the Moon's building blocks formed early in the solar system's history, in the same cold disk of gas and dust that formed the Sun, called the protosolar nebula, rather than forming in the warmer disk of material that Saturn later formed from, called the Saturn subnebula. Surface. The surface of Titan is one of the most Earth-like places in the solar system, albeit at vastly colder temperatures and with different chemistry. Here it is so cold, minus 290 degrees Fahrenheit or minus 179 degrees Celsius, that water ice plays the role of rock. Titan may have volcanic activity as well, but with liquid water lava instead of molten rock. Titan's surface is sculpted by flowing methane and ethane, which carves river channels and fills great lakes with liquid natural gas. No other world in the solar system, aside from Earth, has that kind of liquid activity on its surface. Vast regions of dark dunes stretch across Titan's landscape, primarily around the equatorial regions. The sand in these dunes is composed of dark hydrocarbon grains, thought to look something like coffee grounds. In appearance, the tall, linear dunes are not unlike those seen in the desert of Namibia in Africa. Titan has few visible impact craters, meaning its surface must be relatively young, and some combination of processes erases evidence of impacts over time. Earth is similar in that respect as well. Craters on our planet are erased by the relentless forces of flowing liquid, water, in Earth's case, wind, and the recycling of the crust via plate tectonics. These forces are present on Titan as well, in modified forms. In particular, tectonic forces, the movement of the ground due to pressures from beneath, appear to be at work on the icy moon, although scientists do not see evidence of plates like on Earth. Potential for life. The Cassini spacecraft's numerous gravity measurements of Titan revealed that the moon is hiding an underground ocean of liquid water, likely mixed with salts and ammonia. The European Space Agency's Huygens probe also measured radio signals during its descent to the surface in 2005, which strongly suggested the presence of an ocean 35 to 50 miles, 55 to 80 kilometers, below the icy ground. The discovery of a global ocean of liquid water adds Titan to the handful of worlds in our solar system that could potentially contain habitable environments. Additionally, Titan's rivers, lakes, and seas of liquid methane and ethane might serve as a habitable environment on the moon's surface, though any life there would likely be very different from Earth's life. Thus, Titan could potentially harbor environments with conditions suitable for life, meaning both lives as we know it in the subsurface ocean and life as we don't know it in the hydrocarbon liquid on the surface. Although there is so far no evidence of life on Titan, its complex chemistry and unique environments are certain to make it a destination for continued exploration. The final images from Titan are truly breathtaking, capturing the beauty and mystery of this distant moon in stunning detail. From the complex and ever-changing landscapes to the intriguing and enigmatic organic compounds, these images have given us a glimpse into a world that is both familiar and alien. As we continue to explore the depths of our solar system and beyond, let us never forget the wonders that lie just beyond our reach. So, why not take a closer look at the fascinating images and discoveries from Titan for yourself? Don't forget to subscribe to our channel so you won't miss out on our videos.